So, Nigel, you're Professor of Tectonics, that's plate tectonics. Can you tell me a little bit about the research that you do and how you got into that area?
Yes, sure. Most of the research I do now is related to mountain building, how mountains are constructed from below and how they affect weather patterns at the surface. I originally got into earth sciences because I went up to university to read natural sciences, and I thought I was going to be a physicist, but I discovered somewhere in my second year, I think, that physics wasn't really for me. And the reason for that was partly you can use physics and chemistry and biology, all these different subjects, just to understand how the planet works. But the other thing, which was an important influence, was the field work. We went out to the field in the Isle of Arran in Scotland at Easter, and then I realised that doing science outside and exposed to the elements was a great deal of fun. That was how I got into earth sciences. I joined the Open University in the 1980s when Ian Gass was head of department, and I was lucky enough to get on an expedition across Tibet, and that allowed me to unite two of my interests. One was geology, the other was being in mountains, and I've really worked on particularly Tibet and the Himalayas ever since, and I've had about 30 different PhD students studying and been lucky enough to work with people from all over the world.
So you mentioned field work. What kind of data do you collect in the field? What kind of things do you measure?
Okay, well, traditionally what I've been doing is looking at the bedrock, the sort of granitic samples that crop up at the surface, which provide evidence of metamorphic minerals. Right. For example, we have dark micas with little spots, and those spots are garnets. And sometimes garnets occur much larger. This one I brought out of the stream in the Hindu Kush. And the reason we use garnets is they retain a memory of the pressure they've been to, the temperature they've been subjected to, and you can also date them because they have various radiogenic elements in their makeup. And so you can get a precise age in terms of millions of years for when the rock was at different pressures and temperatures as it passed through the earth and came up in the form of making mountains.
So what are you trying to measure? Are you trying to age date the Himalayas?
Well, in a way, but there's a reason for doing that. What we're really trying to do is to understand how all the rocks at the surface, the pressures and temperatures they've been at different times, because that allows us to create a model of how the Himalayas were constructed. And at a certain point, the rocks get so hot that they begin to melt. And this is an example. You can see here there's a white layer there. That's granite. And that was a molten rock formed deep underneath the Himalayas. This particular sample comes from Nepal. And once the rock begins to melt, the whole mechanical properties of the mountains change at that depth. It becomes much more mobile. The viscosity drops dramatically. Right. So things start moving around.
Why is it important particularly to study mountain building processes like in the Himalayas?
Well, initially the work was really just to understand what happens at plate margins, because the mountains are formed where two plates are colliding. But since I've been working in this field, it's become much more exciting in the sense that we now know that the evolution of the mountains is linked to the climate at the surface, the rainfall, where the rain is deposited, in the case of the Himalayas, the monsoon. You have much more rapid erosion. This is encouraging movement from these ductile layers at depth coming up to the surface. So there are all sorts of feedback mechanisms going on between climate and deep earth processes. So I talk to climate physicists as often as I talk to paleontologists. And the joy of the sort of work I do is I collaborate with a whole wide range of people.
So in terms of teaching then, and I know that you're part of the teaching programme here at the Open University, what types of things, what kind of materials, what would you be writing about in that role?
Well, most of my teaching in recent years has been at third level, and I've written a block on mountain building, and that combines the metamorphic processes of forming garnets and things like that with the melting and the earthquakes. So that's very much along the lines I've been talking about. I've also been involved in the MSc S808 program, where we're looking at the interaction between climate and mountains, because mountains create their own climate system, and also erosion of mountains affects the composition of the atmosphere, which has a long-term effect on climate. So it's a whole range of systems I've been looking at, and that feeds directly into all my teaching.
Students starting in science at the Open University are going to be doing a natural sciences degree just like you did. How soon during that process will they be encountering things like geology and earth sciences?
Right from the start, and they'll be able to use what they know about physics or chemistry or biology to understand more about the planet. At level 2, we managed to take students out into the field in the Lake District and give them a little flavour of what fieldwork is like. So we hope that for people like myself that have a real curiosity about the way our planet works, we're offering them an exciting degree.
That's great. Thank you very much.
Thank you.